Should we begin? All right. So, hello everyone. My name is Tal Saadon. I'm the CTO at Advanced Canna Technologies, and my talk today is gonna be about best practices in commercial cannabis cultivation. Now, this talk is not gonna be about the perfect solution or recipe for growing cannabis because honestly, it doesn't exist. Best practice is something that you adapt to your specific needs, your specific product, your specific abilities, infrastructure, culture of work. There's a lot of things that go into it. So my aim today is to give you tools that will help you develop your own best practice for your specific needs. So as I said, I'm the CTO at Advanced Canna Technologies. Um, I'm basically a cannabis grower. Been growing cannabis for over 10 years in commercial medical industry in Israel, but we started in Israel, but we work worldwide. I started my way as a worker in the fields, also been growing organic vegetables in greenhouses, in open field, and went my way into cannabis. And currently, I'm also working on my PhD in commercial cannabis cultivation. So a little bit about us at ACT. So at Advanced Canna Technologies, we plan and operate cannabis cultivation facilities, not also medical. We've also been working in the recreational market in California, in Portugal, in Israel, and now in Thailand as well. And we're based in advanced intensive agriculture. We come from the agriculture atmosphere. We're looking at efficiencies, at intensification, sustainability, consistency, because we understand that even though today margins in cannabis could be large, and it's not even true today for a lot of countries, but eventually cannabis is a crop, it's a commodity, you need to be efficient, you need to be based on knowledge, you need to be consistent, especially if you're talking about medical operations, you need to be clean, and that's our approach. And you can see some of our partners that we've been going along the way in some of our leading projects. So a little bit about best agricultural practices, what it is, why it's good, and how do we do it. So in a nutshell, best practice is basically a way to do a process that enables us to get consistent results. So that I know that every time I do a process this way, it's very technical, 1, 2, 3, 4, 5, I know that I will get the same result every time. Why we need it? So when we're working in industry, and especially in medical, but not also medical, any company that want to build a business to be consistent, to work throughout time, to be profitable, you need to have good SOPs. You need to have good practices that you know what you're doing, what's the inputs, what the outputs, that I'm always getting the same result, and I can plan my business long term. And again, if we're talking about medical, that I know that I'm going to get clean product that up to standard of what we need in medical. There are all types of best practices. You could say the highest grade is basically research validated best practice. Now that doesn't mean some kind of research in the economy that's disconnected from the field. We're talking about commercially tested best practices with tools of science, of data, and that proven that this specific process gives this specific result consistently with scientific tools. A second type that we can talk about is field-tested best practice. So sometimes I didn't do an academic research about my best practice, but in my field, in my industry, I tested it once, twice, 3 times, and I see that it's working, and it gives me the results that I want consistently. Third one is promising practice. It's something that I noticed that happens sometimes. Certain workers do something a certain way, it gives a better result. I look at it and then I try to push it forward, test it more robustly, and try to implement that on a larger scale. So how we develop? First, we identify where we have issues, where we see lack of uniformity, lack of yield, where we have problems and where we need to fix. We search if there's already solutions to this problem. We don't need to invent wheels when there's already good solutions around. Very important thing is to talk to the people on the ground that's actually doing the work. A lot of the time, the best solution comes from the lowest laborer in the field who's been doing the same work day after day for months, for years, and he sees a certain result when he does a certain way, and you just need to ask them and get the information from them because they usually know the best. You implement these new practices, you measure the impact using quantitative tools, not about, not so and so, numbers, quantitative. And then once you know what's happening, as much as you can, you try to automate. Usually manual be repeatable. Sorry. It's usually harder to have best practice with manual work. So once you have a very good practice, as much as you can, it's usually better to automate. Now a little bit about cultivation, generally speaking, before we even start to talk about cannabis. Now this chart is true for basically any crop. When you're dealing with any type of cultivation system, you need to manage all these things, and it's not even the full picture. A lot of the time, each one of these opens up into more. And you have to understand that you're not necessarily able to control each of them or to optimize each of them, but these are the things that are happening within your system. These are the parameters that determine whether you're going to get good yield, good quality, and that affect your entire process. So even before you talk about the specific crop and the specific needs of each crop, you need to understand the system, you need to understand what its components, and then each crop would have basically a different number for each parameter. Cannabis needs a certain EC, strawberries needs a different EC, rice needs another different EC, but all of them have a certain amount of EC that they can measure, and above that, you're gonna get damage. So it's a complex system. You don't necessarily want or can.
Shake.
Thank you. Thank you. So again, you can't necessarily control all of them in your specific conditions, but at least you need to understand that these are the factors that my system is running on. Another very important concept is limiting factors and the law of minimums. So basically, you could look at cultivation, at yield, as a barrel of water, composed of many different planks. Now, even if all of the planks are at the tallest and at the maximum, but I have one plank that is completely missing, I can't fill even a drop of water in that barrel. Just as an example, let's say I don't have any zinc at all in my system. Everything is absolutely perfect, but zero zinc, the crop is not going to grow at all. I'm going to get zero yield. So your system needs to be balanced. There is no reason to push light to the maximum when I can't irrigate at the same intensity or that I can't control my climate at the same intensity. It's just not going to do anything. It's going to be inefficient, and you're mainly going to waste time and money. So always know in your system what's the limiting factor and try to push it up and try to balance the entire system. A little bit about cannabis, the basic, the life cycle. So originally, like any type of crop, cannabis starts with seedling, we go to vegetative phase, changes throughout your cultivation method, how long it's gonna be. We flower, then we harvest. Now, usually in commercial cannabis cultivation, we start with clones and not seed, because seeds have much more variability and we want more genetic uniformity. But you do go with vegetative and then flowering. Now, as you can understand, for example, with vegetative, you can have 2 to 8 weeks difference in your cycle. Now, if you have 8 weeks of vegetative phase or 2 weeks, it affects how many cycles I can run per year and how many money I can make from the same square meter repeatedly. So again, and also it affects which conditions I'm gonna need to give along the way. Usually if you give more veg time, you need bigger plants, less plants per square meter. It's a different system. So you need to understand what you aim for, why you do, what you do, and balance your entire system and get the full picture. A little bit about crop requirements. So cannabis, like many other crops, it has certain parameters that fits it best. Now, if you look at what's being done in the commercial cannabis industry, you'll see very large variability, people growing at very low temperatures, very high temperature, very different ECs. It's all over the place. And even though research about cannabis is not that advanced, there is enough research to set the baseline and to know what the crop needs. So the crop comes from hot climate, from Asia. It likes heat. All the experiments being done have shown that cannabis does optimal photosynthesis at around 28 degrees. But you'll see a lot of growers, for example, that grow at 22 degrees. And why is that? Because growing at 28 degrees pushes the entire system to very high speeds. You can compare it to a car driving very, very fast. And if you make a wrong turn at a car driving very fast, you're gonna crash and it's gonna hurt. On the other hand, if you're growing at a lower temperature, at a lower speed, you can navigate more easily. So the pests don't multiply as fast at lower temperature. The crop doesn't grow that fast, so you don't need to irrigate that much, to feed that much. So it gives you a tool to balance your system. So temperature, for example, is a very strong tool. How do I manage my system? If my fertigation system is not advanced enough to feed as much as needed, I can drive down the temperature and keep the system balanced. Another critical thing that you can see here is light. Also, large variability in the amount of light that's been given. Some people giving 800 micromole, some people even talking up to 2000 and more. Most research shows that cannabis is a very high light intensity crop. It can absorb tremendous amount of light, more than more crops, and produce biomass. But again, light is the energy of the entire system. It's the driving motor. If I'm putting light at 1,500 micromole or even 2,000, again, it's like driving at 400, 500 kilometers per hour. Most people don't know how to drive that fast, and your entire system needs to know how to accommodate to that speed. So it's not necessarily the best thing for you. Maybe the best thing for you and for your business is to drive a little bit slower, but make sure that you can drive for a very long time. So there was a lot of talk here in past lectures about planning and operations, and I fully agree that planning is one of the most fundamental parts in any cultivation system, because that basically sets your roof. Because if I put 1,500 micromoles of light, but my HVAC system doesn't know how to support all that heat, or doesn't know how to take all the water out of that system, it's not gonna help. I'm not gonna be able to use all that light. I'm probably gonna see high humidities, get mold, have problems. So planning is really critical. And when you plan, in my opinion, 4 of the best critical elements is be science-based. Crop sciences weren't invested yesterday. We have over 200 years of crop sciences to rely on. Even though cannabis is a new crop, there is still a lot of things to go on. We don't need to invent wheels. Be data-driven. Today we have a lot of sensors, a lot of technology. You need numbers. It doesn't work to run a business on, I think it will be like this, or it's about this and that. Eventually you need to put a number in the controller, how much water to give, how much fertilizer to give, what's the set point in the climate controller. You need to be quantitative and data-driven. And of course, cost benefit. You can build a spaceship that would cost tons of money, it would cost tons of money to operate, but it might not be very efficient. It maybe produce a lot, but not enough to justify the cost. So again, for your specific crop, for your specific needs and setting, you need to understand what the best practice also in terms of cost benefit. So when you do planning, you need to do it proper, take your time, because usually it's something that you can fix later. Once I have a facility built, up and running, to shut it down and to start to do maintenance and upgrades is usually completely impossible or very, very hard and expensive. So take your time, plan properly, do it well, and do it once. Be very specific to your location, to your needs, and look at the small details. They usually make the biggest difference. And your infrastructure also needs to be in a certain way that it prevents mistakes from even be able to happen. For example, with a situation that we came to a facility, we had the rooms, each two rooms were connected with one gutter. We would deal with the pest in one room, and the pest would flow to the other room through the gutters. And we would deal with the other room, and they would flow back. Now, if initially we weren't planning the system with gutters connected, the pest couldn't flow from one room to the other, and that problem could never even exist to begin with. So think at how you prevent problems from even happening in the first place. And of course, later you need to operate this system. Again, prevention in maintenance comes before everything. It's easier to prevent things than to solve them. Keep your protocol. If you have a protocol, don't be overly reactive. Don't change too much. Stick to what you're doing. Collect data. Learn from your mistake and improve from time to time. And of course, your SOP needs to be very simple and clear, like Brendan from Antina mentioned, even for non-experienced labor. Anyone coming to the facility can see a list of actions, follow them, and get the result. So a little bit about when it's important. So obviously, when you're growing outdoors and I don't have any control of the climate, it doesn't really matter how much I know about climate control because I can't control it. So it doesn't really help me. But when I'm going to greenhouse, which is semi-climate control, or an indoor, which is fully climate control, I need to know exactly how much refrigeration power I need to put, how much light I need to put, how much drainage I need to put. Everything needs to be known. So yes, you can get much better results, but you need to know a lot more, and you need to operate this entire thing. And it obviously also comes with a CapEx, but also with results. So usually the results you can get in an indoor, you cannot get in open field. And the amount of cycles that you can get in an indoor, you can't get with open field. A little bit about best practice tools. So in order to have best practice, you also need good tools. Because again, maybe I know a lot, but if I don't have the right tools to implement all this knowledge and to control all these systems, it's not going to help me. I can't implement my know-how. So you need good software. You need to do proper planning with the right tools to know exactly how it's going to look, where things are going to be stationed, know that I can pass, that I can manage, that people have access. Need to have the right hardware, the right system, fertigation, climate, sensors. Today, sensors are becoming cheaper and cheaper. There is no reason to guess what you can know. You can just put sensors in the soil, on the plant, in the air, and know and have quantitative data on your system, know what's happening, not guess, and then you could analyze that data, compare it to your results, to the yield, to the quality, and learn and advance. And also on the day-to-day operation, clothes, gloves, scissors, little things that need to be cleaned, need to be maintained, so you can biosecurity can be at a good condition and the best practice. This is an example of non-best practice. So this is a farm in California. It has here 10 big rooms, another 20 rooms in a very close by building. You can see fertilizers and a drink, a Coke, all in the same place. Everything is handwritten. Someone can cross things off. You can't manage a big commercial cultivation multi-million-dollar facility like this. It's simply not going to work. Eventually, statistically, someone's going to do a mistake, and that mistake is going to cost you. Or again, even cost someone health. You don't mix drinks and food with nutrients. So, tools, so we have a variety of tools. Substrate is something that is really critical. what we grow the plants in. So there are a variety of substrate. This is cocoa, there is rock wool, there is perlite, there is peat, a lot of variety. I need to understand that each substrate is different. It has different properties, different benefits, different downsides. It needs to have different preparation in order to get good results. Almost all of the substrate are not simply plug and play. You need to at least to do some initial preparation for it to get good results. And a lot of the time people fail there. They don't do a small step in the beginning, and then the plants get underfed and begins a cycle of mistake that is really hard to correct. And this is, in my opinion, a beautiful example of a few small things that make a huge difference. So the first thing, again, especially in medical setting, but not only, is that this is disposable. I don't need to have plastic pots. I don't need to clean them. I don't need to dry them and then put them back. And all this hassle saves me tons of labor. The substrate is clean, no disease, no weeds. And then the package. So the package is biodegradable, which also helps me sustainably because then my waste is not a problem. I don't have plastic waste. And also, it enables more oxygen into the roots, air trimming of the roots, better root architecture, and just by replacing the wrapping from plastic to biodegradable fabric. So when you're looking for a solution for your facility, you need to find these products that give you the small edge. Think one step forward that gives you much better solution. And as an example, this plant has been 1 week in veg. Some people grow 3 weeks, 4 weeks. This is 1 week in veg. It's ready to shift into flower, and we see amazing results and very good yields. Once your system is precise, you can go down with the substrate volume. In the old days, we started with 20 liters, we went down to 9 liters, to 6 liters. Today, we grow in 3.5 liters. Now, we can only do that if your system knows how to handle this, because when you're growing in 3.5 liters, you need to irrigate many more times, you need to feed many more times, everything is much more intense, you have less buffering capacity, but once your system is at that level and you have best practice, I'm reducing the amount of substrate I buy, I'm reducing the amount of substrate that I need to throw, that I need to carry. A lot of things go into that, and that's a part of the benefits you can get from doing things right. This is an example of some fertigation system. So again, this is the right edge of the complicated full control indoor system. This is not necessarily right and true for everyone. If you're growing outdoors, using compost, using slow release fertilizers, your system can be very simple and be based only on water or water with 1 part nutrients. But when you want true full control, absolute control, medical grade, in indoor, in clean environment, this is the complexity that you need to get to. And again, you need to know how to operate all this complexity, and you need to plan all this complexity right. If you did a mistake here, again, it's going to be hard to fix, and you're probably going to pay a lot for it. If I did a mistake in open field, usually I get hit less hard. The other part is climate and light. These are the 2 biggest engines of our system. With light, we always go with LED, fluence. We choose the best. We know that we're going to get amazing results consistently. And when you invest so much in this entire system, as we spoke about limiting factors, light is our absolute rooftop, because that's the energy available to produce sugar, and then the plant turns these sugars into biomass. That's the absolute limit of our yield. But again, if I don't have correct HVAC system to control all that heat, to control all the humidity produced by the plant, all the light is not going to help me. And we've seen many times growers going for 1,500 micromole. The rest of the system can't handle it, so they die down. They operate at 60%. but then you wasted so much money on lights, on 40% lights that you didn't need. So everything has to be balanced. This is a little bit about the results that we can get when we have really good practice. So this is our farm in Portugal. It's based on, this data is based on 6.5 tons that we grew in 1 year, 101,000 plants. And you can see here basically yield versus accumulated light. And you can see a very, very nice linear correlation between them. So in this particular case, the system was well built, very intense, could support the plant and its needs. And our rooftop was basically only the light. So our greenhouse, we did have some light supplementation, but it was mainly based on sun. And you can see that the more sun the plant got, the more energy available to it, the more it produced. Now, if I didn't feed it enough, you wouldn't see this linear graph because my limiting factor was water or nutrients and not sunlight. Some more results of what you can get to when you do best practice, and obviously also very good genetics. You can see here from our farm in California, indoor 36% THC, 42% total cannabinoids, 4.3 total terpenes. This plant is almost 50% active material. It's on the verge of extract. And you can't drive the plant that hard when you don't have the right system and the right tools. But a small side note that I do want to say here, I don't believe that this is right for Thailand. This is right for a very mature market, for people who are very experienced in cannabis. What we see here in the Thai market is a lot of newcomers, a lot of people that haven't smoked cannabis in their life. And if in your first time in life, you're gonna smoke a flower with 30% THC and above, honestly, it's not gonna end well. So even though you can push it so hard, you don't necessarily want, and you have to take the genetics into consideration here. I personally believe that 1-to-1 with CBD, something that's a bit more balanced, would be more right, at least in the first year of the Thai market. Some more results on how things can look from our indoor in California. And a little bit about today in Thailand. So this is our new facility here in Thailand. It's called Actera. It's here 40 minutes from central Bangkok, 2,000 square meters of indoor, implementing all the best practice that we spoke so far. Really intense indoor system with Fluence, with HVAC, with the best substrate, very advanced fertigation system, really implementing everything that we talked so far with our partners Terra, which also have a dispensary line and processing facility. So basically together with them, we have a vertically integrated partnership here in Thailand. We know how to produce, we know how to process, we know how to sell. And today, as you can see here, floor is already done. Wall will be coming up in a few days, starting to operate around mid-May and have materials ready around August. And basically, this is a call to any international brands that are looking for a home here in Thailand to produce under their name with the best quality. We're here to help. We have partners here. We're on the day-to-day here. Anybody who needs help here in the cannabis industry in Thailand, our partners at Terra would love to help. So thank you for your time.